Hello everyone, this side Macha Rowan. I am a student at Government Engineering College Bharuch and I am studying in second year Computer Engineering department. This is a small project which I created for my assignment in the Digital Fundamental subject. So this is a project which I have used to make an hour timer such that it will count time for up till 1 hour. This is based on the counter logic which is made using JK flip-flops and some basic logic gates. So here I have used two modules. These each modules are the same modules which are cascaded upon each other such that the reset signal from this module is used as the clock for the second module. Now each module has to be inserted with a clock, a pause button as well as start slash reset button. The clock will provide the impulse such that it will increment the counter by by one for each second. Now I will demonstrate how this works. Firstly, when the project is started, we need to start the project. After clicking the start button, the timer starts ticking. That is, after each second, the seconds display starts incrementing by one each second. Now, if I increase the time, then let's say I am fast forwarding it. This will reach 59 seconds and then this will reset to 0 and the signal will be passed on to the second module which will increment the minute counter by 1. Similarly, if it again reaches 0, it will also increment the counter by 2. So this is how my hour timer works. Now I will explain how each module is made up and how the logic inside it is working. So let's go to the dashboard. So this is my module. This is the overview of my module. In this module, we have used 6 JK flip-flops, one reset logic, and a display to display 0 to 59 seconds in the timer. Here, this button will be the start reset button, this button will be the pause button, and this will be the output for the clock for the next module. So let's start by the first JK flip-flop. We will name this, let's say, JK flip-flop 0, flip-flop 0, let's say. So for the flip-flop 0, the J input will be nothing but the J input will be nothing but the start input as well as the will be nothing but the and of the start as well as the not reset signal. We are using not reset signal since we want the J to be 1 and K to be 1 for the toggling of the values such that the counter will work. So for the not reset signal, initially the reset condition will not be met, so the not reset signal will be 1, and upon switching on the switch we will get the output as 1, and since the output will be 1, J will be equal to 1 and the K will also be equal to 1 for the flip-flop 0. And since the J and K of flip-flop 0 are flip-flop 0 are 1, the Q will also toggle. So since Q was 0, the Q now will becomes 1. So this one will be passed on to the next J as ANDed result of the previous Q1 Q of flip-flop 0 and the not reset signal. We are using not reset signal and the ending here because if the reset signal is met, then not reset will be equal to 0 and ending with 0 will result into 0. So the J value of the flip-flop 1 for the reset condition will be 0 and the value of K will be ORing of the previous Q or the reset signal. So if the reset signal will be 1, the K value will be equal to 1, and since J equal to 0 and K equal to 1 is the reset trigger, the Q and Q bar will be set to 0. So that's why we are using the reset signal. And now the output of the flip-flop 1 will be ANDed with the previous flip-flop so that the next output so that the next bit could be triggered. If these two outputs are triggered, then only will the third bit trigger. Then only the third bit counter will start moving. Say this is 1. This is 2 to the power 0. This will be 2 to the power 1. This will be 2 to the power 2. Similarly, 2 to the power 3, 2 to the power 4, 2 to the power 5. So after ending this, the result will further be again ANDed with the not reset and or with the reset and pass to the J and K respectively of the flip-flop number 3, or let's say flip-flop number 2 according to one naming scheme. This will again be ended with the previous such that when the previous three are enabled, then only will it be passed on to the fourth JK flip-flop. So in this way we are cascading all the signals such that the last JK flip-flop will only be triggered if and only if all the previous JK flip-flops are triggered. Now the outputs of each Q are taken as a fundamental value. For flip-flop 0, it is 2 to the power 0. For flip-flop 1, it is 2 to the power 1. For flip-flop 2, it is 2 to the power 2. For flip-flop 3, it is 2 to the power 3, and for so on. So here from up to down, it is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5. This will be the binary representation. Now, this binary representation is the representation of 59 in decimal. We wanted 59 because we want to reset the counter when the timer reaches 59. So we are using this as a reset logic. Now this will also, now these connections are used to display the timer. Now let's test if this works. See, now I have not enabled. Let's say I enable the timer. Here you can see it, the timer is ticking. 1, 2, 3, 4, 5, 6, and the pause button. Since the pause button is ANDed with the clock signal will not be passed on, since the ANDed is the bubble and the pause signal will be inserted at 0 into the AND. So is 0 in AND will result in the output being 0, so the clock will not be passed and the flip-flops will remain at a constant state, that is they will be disabled and not function. After we remove the pause signal, the clock will be transmitted as usual and the clock will continue and the timer will continue as it should. Now I will explain why I have used a NOT gate here. Since this whole since this whole line is the not reset signal, the next output will be passed when the switch is triggered. The not reset will be passed on to the clock as a clock for the second module. And if you start the then it will if you start then the module second module will receive the enabled signal on the first tick, which is not possible, which is not useful. We want it to tick only when the first timer reaches 59 seconds. So that's why we are using it as not. That is, we will provide it with the reset signal. If we provide it with the reset signal, when this counter resets, only then it will provide the tick to the next counter or the next module, should I say. So this is how my JK flip-flop counter works, and I hope you understood it well. Thank you very much.